Hello friends, this is Swarupa. Welcome back to my channel. In this video, I am going to explain about the linear programming problem using Big M method. We use same simplex method algorithm for the Big M method. So there is no much difference between simplex method and Big M method. In simplex method, the problem is having the less than or equals to constraints. In that case, we need to add the slack variables plus s. That means in simplex method, the problem consists of less than or equals to constraints. In that case, we need to add the slack variables plus s. And this method we have already discussed in the separate video. Now we are going to discuss about the Big M method, which consists of the greater than or equals to constraints. In Big M method case, we need to do two things. First one is subtract surplus variables. And second thing is add artificial variables. Plus a. Let us see the problem using Big M method. Here, solve the following LPP using Big M method. Min z is equals to x1 plus x2 subject to 2x1 plus x2 is greater than or equals to 4 and x1 plus 7x2 is greater than or equals to 7, where x1 and x2 is greater than or equals to 0. So now we already discussed that in Big M method we have to do two things: subtract surplus variables s and add artificial variables a. That means first we need to subtract surplus variables and add artificial variables in both the constraints. Before that, we need to write the objective function. Min z is equals to x1 plus x2 subject to 2x1 plus x2. We have to convert inequalities into equalities by subtracting surplus variables and adding artificial variables. Subtracting surplus variables means s1 and adding artificial variables means a plus a1 is equals to 4. And in second constraints, x1 plus 7x2 subtract surplus variables minus s2 plus add artificial variables plus a2 is equals to 7. And we need to balance both the objective function and the constraints. Here only x1 and x2 are there. There is no s and a. In order to balance the objective function and the inequalities, we have to do the same thing in objective function. So min z is equals to x1 plus x2 plus 0s1 plus 0s2 plus ma1 plus ma2. After balancing the objective function and equality, next we need to frame the initial table. This is the initial table. Cj is the coefficient of objective function. That means coefficient of x1 in objective function is 1. Coefficient of x2 in objective function is 1. Coefficient of s1 in objective function is 0 and s2 is 0 and a1 is m and a2 is m. bv means basic variable. cb means coefficient of basic variables. This one r1 row 1 and row 2. Basic variables. bv means basic variables. Coefficient of two constraints a1 a2. Coefficient of a1 is m and a2 is m. Next, we have to write the coefficients of the two equalities. 2x1, that means 2, plus 1x2 minus 1. Here minus s1 means the coefficient is minus 1 and s2 coefficient is 0 and a1 coefficient is 1 and there is no a2 in first constraint. This is first and this is second. So we need to write 0 and the solution is 4. And in second equation, the coefficient of x1 is 1, coefficient of x2 is 7, coefficient of s1 is 0, coefficient of s2 is -1, coefficient of a1 is 0, coefficient of a2 is 1, and the solution is 7. This is the initial table. We have framed the initial table, and next we need to find the key element. For that, first we need to find the zj value. Zj means, how to find the zj value means, there is a formula. Zj is equals to summation I equals to 1 to 2 cbi into aij, or simply coefficient of basic variable of r1 into element plus coefficient of basic variable of r2 into element. See how we have to frame that values means, coefficient of basic variable is m into element 2 plus coefficient of basic variable m of r2 m into element 1. That means m into 2 plus m into 1, 2m plus m, that means 3m. m into 1 plus m into 7, 8m. m into -1 plus m into 0, minus m. m into 0 plus m into -m, minus m. m into 1 plus m into 0, m. m into 0 plus m into 1, m. m into 4 plus m into 7, 11m. Next we need to find the Cj minus Zj value. Cj minus Zj value. Cj is 1. 1 minus Zj value is 3m. 1 minus 3m. 1 minus 8m. 0 minus m plus m. 0 minus m, m. m minus m, 0. m minus m, 0. The optimality condition for minimization problem is, all the Cj minus Zj values should be greater than or equals to 0. See here, we are having two negative values, 1 minus 3m and 1 minus 8m, and these are greater than or equals to 0. So we have to form the next iteration table. For finding the next iteration table, we need to find the key element. For that, first we need to find the key column. For finding the key column, we have to find out the most negative value in Cj minus Zj. In both values, the most negative value is 1 minus 8m. That means x2 is the key column. Next we need to find the key row. For finding the key row, we need to find the ratio. That means 4 divided by key column. 4 by 1 is equals to 4 and 7 by 7 is equals to 1. Here the least positive value is 1. This is the key row. This is a key column. This is the key row. And the intersection point is called the key element. This is the first iteration table. We need to frame the values for this iteration table 1. These same values in the initial table. And here, what are the basic variables means, here the a2 is the leaving variable and x2 is the entering variable. That means a1, and we have to write x2 instead of a2. Coefficient of x2 is 1 and coefficient of a1 is m. And for finding the row 3 values, there is a formula. Before that, we have to find the R4 values. For x2, we need to divide the old element divided by key element. 1 divided by 7, 1 by 7. 7 divided by 7, 7. 0 divided by 7, 0. Minus 1 divided by 7, minus 1 by 7. 0 divided by 7, 0. 1 divided by 7, 1 by 7. 7 divided by 7, 1. And for finding the O3 values, there is a formula. Old value minus key column value into R4. Old value is 2. That means old value is 2 minus key column value. This is the key column. Key column value is 1. 1 into R4 value. R4 value is 1 by 7. That is equals to 2 minus 1 by 7 is equals to 13 by 7. Next, for x2 we need to find old value is 1. Old value is 1 minus key column value is also 1 into R4 value. R4 value is 1. That is equals to 1 minus 1 is equals to 0. First value is 13 by 7. Second value is 0. And the next value, here the old value is minus 1 minus key column value is 1 into R4 value 0 is equals to minus 1 minus 0 is equals to minus 1. Minus 1. Next, here old value is 0 minus key column value is 1 into R4 value is minus 1 by 7. That is equals to minus of minus 1 by 7 equals to 1 by 7. Next, A1 value. Old value is 1 minus key column value is 1 into R4 value is 0. That is equals to 1 minus 0, 1. Next we have to find the A2 value. Old value is 0. This is 0. Minus key column value is 1 into R4 value 1 by 7. That is equals to minus 1 by 7. Here old value is 4 minus key column value is 1 into R4 value 1. 4 minus 1 equals to 3. That means solution is 3. This is the way to find the R3 values. Next we need to find the ZJ values. That means m into 13 by 7 plus 1 into 1 by 7. Like that we have to find. Here 13m by 7 plus 1 by 7. M into 0 plus 1 into 1. 1. m into minus plus 1 plus 1 into 0 minus m into 1 by 7 plus 1 into minus 1 by 7, m minus 1 by 7, m into 1 plus 1 into 0 m into minus 1 by 7 plus 1 into 1 by 7. Here we need not to find the A2 values. Simply we should strike it off. No need to find the A2 value. M into 3 plus 1 into 1, 3m. Next, Cj minus Zj value. 1 minus 13m by 7 plus 1 by 7 minus 13m minus 1 by 7. 1 minus 1, 0. 0 minus minus m, 0 minus m minus 1 by 7, 1 minus m by 7, m minus m, 0. No A2 value. Here all the Cj minus Zj values should be greater than or equals to 0, but here the two values are having negative values. So we need to find the next iteration table. For that process we need to find the key column and key row. Here in both the cases the most negative value is the minus 13m minus 1 by 7. That means this is the key column. Key column. Next we need to find the key row. For finding the key row we have to divide the solution with key column. 3 divided by 13 by 7, that is equals to 21 by 3, 13 is equals to 1.6. 1 divided by 1 by 7 is equals to 7. Here the least positive value is 1.6. This is the key row. This is the key column, key row. And the intersection point is called the key element. And now we have to frame the iteration table 2. This is the second iteration table. We have to write the coefficient of basic variables. x1 is 1, x2 is 1, s1 is 0, s2 is 0, a1 is m and a2 is m. Here we need not to write a1 because x1 is the entering variable and a1 is called the leaving variable. That means x1 and x2. For finding the x1 values, the coefficient of x1 is 1, and for finding the x1 values, divide the old value with the key element. Old value is 13 by 7 divided by key value, that means 1. 0 divided by 13 by 7, 0. Minus 1 divided by 13 by 7, minus 7 by 13. 1 by 7 divided by 13 by 7, 1 by 13. And there is no a1 and no a2 in both the cases because a1 and a2 are the leaving variables, x1 and x2 are the entering variables. For finding the x2, that means there is a formula, same formula is there for finding the R6. See, old value is in x2, old value is 1 by 7, minus key column value. Key column value is 1 by 7 into R5 value. R5 value is 1. That means 1 by 7 minus 1 by 7 equals to 0. That means 0. Here the R2 coefficient is 1. And the next old value is 1 minus key column value. Key column value is 1 by 7 into R5 value. R5 value is 0. That means 1 minus 0, 1. And next old value is 0 minus key column value is 1 by 7 into R5 value. R5 value is minus 7 by 13. That is equals to 0 plus 1 by 13. That is equals to 1 by 13. Next old value is minus 1 by 7. Minus 1 by 7 minus key column value is 1 by 7 into R5 value is 1 by 13. That is equals to minus 14 by 91. Here the solution is here. Old value is 1 minus key column value is 1 by 7 into R5 value is, we have forgotten to find the R5 value here, 3 divided by 13 by 7. 3 divided by 13 by 7, that is equals to 21 by 13, 1.6. R5 value is 1.6. That is equals to 1 minus 1.6 by 7. That is equals to 4 by 7. Next we need to find the ZJ value. 1 into 1 plus 1 into 0, 1. 1 into 0 plus 1 into 1, 1. 1 into minus 7 by 13, 1 plus 1 into 1 by 13, minus 6 by 13. 1 into 1 by 13 plus 1 into minus 14 by 91. 1 by 13. There is no A1 and no A2. 1 into 1.6 plus 1 into 4 by 7. 25 by 7. Next, Cj minus Zj value. 1 minus 1, 1. 1 minus 1, 0. 1 minus 1, 0. 0 minus 6 by 13, 6 by 13. Sorry, here minus 1 by 13. 0 minus 1 by 13, 1 by 13. Now we have to check the optimality condition. All the Cj minus Zj value should be greater than or equals to 0. See, check. There is no negative value. That means we have attained the optimality. This is the way to prepare the LPP model using the Big M method. Now we have to find out the x1 and x2 values. Here the x1 value is 1.6 and x2 value is the 4.7. I think here the solution is wrong. Calculation is wrong. See, for finding the ZJ, 1 into 1.6 plus 1 into 4 by 7. We got 15.2 by 7. This is the solution. Means Z is equals to 15.2 by 7. See, we can check this whether it is correct or not. We have to substitute these x1 and x2 values in the objective function. Means Z is equals to x1 plus x2. That means x1 is 1.6 plus x2 is 4 by 7. 7 into 1.6 divided by 7 plus 4 by 7 is equals to 11.2 plus 4 by 7 is equals to 15.2 by 7. So both the values are equal. The optimality is reached. This is the way to prepare the LPP model using the Big M method. Thanks for watching. Please subscribe my channel.